Hello everyone and happy Thursday. We're going to do a free response question today to try to keep on getting ready for the AP test next week. So the question we're going to do today is this one. It is question number 3 from the 2018 AB test. It is a non-calculator question, though we could use a calculator next week if we needed to, because we're allowed a calculator for the entire test. But let's look at what the question asks. The graph of the continuous function g, so this is g, the derivative of the function f is shown above. So g is the derivative of f. The function g is piecewise linear from -5 to 3, and g of x equals 2 times the quantity x minus 4 squared from 3 to 6. So what they're saying is this is a line, 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 parabola from 3 to 6. If f of 1 equals 3, what is the value of f of -5? So in this situation, because g is equal to the derivative of f, if we were to take the integral of g of x, this would give us our displacement of f, because taking the integral of the derivative of something gives you the derivative or the displacement of that function. They want us to find the value of f of -5. This thing right here is our initial condition. This is our starting value. We are trying to go backwards to -5. So we're going to take the integral from 1 to -5 of g of x with respect to x. Looking at this, this is a 1 by 2 triangle, so this has an area of 1. This is an area of 0. This is a 1 by 3 triangle, so this has an area of -1.5. And then this is a square that's 3 by 3, so this has an area of -9. If I add all of these together, I'd get -10.5 plus 1, which is -9.5. But that would be if I was integrating in this direction. Because I'm integrating in this direction, my signs are going to be reversed, which means that this value is equal to +9.5. But this is not our answer. This is our displacement. This value right here is basically our anchor point. So if we are trying to go from 1 backwards to -5, we would take this 3 value and we would add on 9.5, which means that f of -5 would be equal to 12.5. If you want to think of this in another way, if the value was at 12.5, then it would have decreased by 9, decreased by 1.5, stuck around for a bit, and then increased by 1. All of that would have ended up getting us to the value of 3. So now we're just going in the reverse direction. The next thing that they ask us to do is to evaluate the integral from 1 to 6 of g of x. So they want us to find the area underneath this curve. Now this bit is no big deal. This thing is an area of 4. So we know that we have 4 plus the integral from 3 to 6 of this function, and this function is 2 multiplied by x minus 4 squared with respect to x. And that's what we need to take the integral of. So you could just use your basic integration rules because the derivative of the inside of this is going to be 1, so we don't really have to worry about any chains or anything like that. So we would have 4 plus 2 multiplied by x minus 4 to the third power over 3, evaluated from 3 to 6. Now, if I'm doing this on the AP test, remember that we don't need to simplify answers. And so since I don't need to simplify answers, here's how I'm going to write my final answer. I will have 4 plus 2 times 6 minus 4 cubed over 3 minus 2 times 3 minus 4 cubed over 3. I don't need to put a plus c in here because I'm taking a definite integral, not an indefinite integral, which means that this thing is my final answer for part B. The third question says, from -5 up to +6, on what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. So, f is increasing if f prime is positive. F prime is G. So, we want to know in what open intervals the graph is increasing. Sorry, not this graph. The function f is increasing. So, if we look at this thing, G is positive between -5 and +6 from 0 to 4 and from 4 to 6. It's not going to be positive at 4. So we would be looking at the space from 0 to 4 and from 4 to 6. For the second bit, we know that f is concave up if f double prime is positive. F double prime is equal to g prime of x. So now we're interested in what the slope of the graph of g is. G has a positive slope from -2 to -1. From 0 to 1. And from 4 to 6. So if we're looking for our overlap, because we want both of these things to be true, we would say that our overlap looks to be from 0 to 1. Oops. I can clip this into place on my clipboard. That's what a clipboard's for. From 0 to 1. Then from 4 to 6. And I would say that that's my answer. Lastly, find the x-coordinate of each point of inflection of the graph of f. Give a reason for your answer. So an inflection point occurs when the second derivative changes signs. Start by writing that. Get your point for your explanation. So, inflection point occurs when the second derivative changes signs. Remember, it doesn't just need to equal 0, it needs to change signs. So that is f double prime of x, which is equal to g prime of x. So we're looking for places where g prime changes signs. Here I'm going from 0 to positive. That's not a change of sign. Then here I go from 0 to positive again. The only time that I actually change signs is this spot right here. At least that's the only one that I'm super confident in right off of the bat. My slope changes from negative to positive, and so I would say that g prime of x changes signs at x equals 4, because that's where I'm going from negative to positive. This area right here, I'm frankly a little unsure of. We're going from a positive value to a negative value, but we're not immediately going from a positive value to a negative value. I have positive concavity here, then I have no concavity here, then I have negative concavity here. So the question is, where would the sign change occur in this situation? I could see an argument for saying that there's a point of inflection at either 1 or 3, but I'm frankly not confident in choosing either of those. So you could make a note of that in your answer. You could go for it. I don't have the answers in front of me, so I'm not going to put down, or I don't know what they wanted you to put, but I would stick with this answer and go with the values that I am absolutely confident are true, rather than putting down things that I think might be true or might not be. And I would call it a day, and at the most I'm probably going to lose 1 point there, which I'm okay with. So hopefully that was helpful. I will, in the comments, I will look up what the required answer was, and I'll write down what that was supposed to be. So I hope everybody's doing well. Hope that this was informative. This is a question that I could see taking some sort of form on the AP test next week. So you should make sure that you are comfortable with all the aspects of this question. I look forward to talking to you all again soon, and I hope everybody continues to be well. Bye.